Good morning, everybody. So today we're going to have a little discussion on what kind of math concepts connect Algebra 1 to Geometry to Algebra 2. So my first question is, just get some ideas what some of those concepts are.
I'd say that solving multi-step equations would be something that's consistent throughout, even in geometry with angles.
So you agree with slope. How does that connect with equations?
Speed must be solved for it, so we would have to do the algebra and the geometry at the same time.
So,
and then getting into, I just lost my train of thought. I guess just graphing like anything in geometry, you have to know the slope, and then you use the slope to determine if it's like parallel perpendicular. Then you can do quadrilaterals.
is that another use of equations combining with graphing?
Well,
Yeah.
Yeah, and definitely slope, because you got another parallel, perpendicular, same slope, inverse opposite or opposite reciprocal. Yeah.
So Jen said about multi-step equations when we started, and we see that there is some in geometry. So how can that also expand into Algebra 2? Where does that go?
So many more.
More.
So many more equations.
So many more equations. Yeah.
Systems as well.
Systems.
Yes.
Absolute value. My gosh.
So you would say more advanced functions besides just the basic linear, correct?
Oh, definitely.
Absolutely. It increases the rigor as you go on mathematically, and the multi-step equations and the way in which we solve those is very similar to slope-intercept form when it's not in that form to begin with, which translates into finding angles or graphing lines or anything else that involves systems. So it's coherent throughout.
So let's return to graphing, because that seemed to be a thread that we're discussing as well. And you talked about just doing the slope and y equals mxb. But where else, for example, does geometry deal with graphing?
Graphing circles is one. There's not much slope with circles, but it is that equation and understanding how to plug in different points.
Have you thought about what does transformation mean versus
and then
algebra versus geometry versus algebra 2? That's another thread. Do you agree?
Yeah.
Yes.
Yeah, well, because in Algebra 1, you are transforming lines or dilating or compressing, and then you move to shapes in geometry and more advanced, I believe, three-dimensional figures as you continue on, right?
I think so.
Is that
Do you
right?
use the algebra side when you do the geometry? For
Yes.
example, do you do the transformations based in points?
Yeah, we
Yes.
do point form and vector form, and then it's called algebraic form, where you write the like x plus horizontal shift and then the y plus or minus the vertical shift, and then that's exactly the same. And then I always try to pull from like when it's in the parentheses in algebra, it does the opposite, and that's kind of what it is with some of the geometry as well.
And then when we move on to algebra 2, what would be the continuation?
You mean like for like conic sections? You mean things like that we really don't seem to get to?
Yes, but
Yeah.
we do in algebra 2, what kind of transformations? How are our transformations different than the transformations of algebra 1?
Oh, they're not exactly linear anymore. Like, right.
Quadratics,
Quadratics, absolute value. Yeah.
And would you say, like algebra 2, we have our more advanced functions? Are we still doing transformations?
Oh, definitely. I try to get the kids. I don't exactly tell them. I try to get them to see it on their own, like, what is happening, and try to get them to tell me, instead of telling
pattern recognition, which is big geometry as well.
Yeah. So with our last topic, moving away from being a concept-based continuation, can we say there's some process goals that we share, where you were saying about patterns and you were saying about getting them to do more critical thinking? What would be an example on the algebra 1 level that would be a good way to show like problem solving, how that would match out to the higher levels?
I think just again, translating lines or understanding If something shifts from the left to the right for a linear equation, then you're looking at that opposite factor, just like you were talking about with geometry or with algebra 2. So building those connections is imperative, and getting our students to see that at each level it's further expanding is vital to their success. They have to be able to do those things.
So you agree?
Yeah.
How can you expand on what Jen said?
I didn't have a thought ready for that one.
It's
I'd say another thing to diverge from that, is that allowed? Another thing with geometry proofs is a huge thing.
Yes.
And then we always go back and say, well, in algebra, you explain your reasoning, you explain your step, you add to the both sides. So it's additive property or addition property. Like, we're still doing that. You've proved stuff before. Now you just have a wider vocabulary of things to choose from for specific geometric proofs.
So it's like each subject is a stepping stone. So like we touch base with it in algebra, and then we get more in depth in geometry, and then it goes further in depth in algebra 2.
Right. So, and final, so we talked about what algebra does to geometry. So what are some of the more process goals at the algebra 2 level? Like, where do we move? Like what Peyton was saying about how she was doing the proofs and making them think. Can you just describe like how critical thinking is applied at the algebra 2 level?
Well, at the algebra 2 level, it's funny that you were talking about proofs, because yesterday, I think it was yesterday, I asked somebody, how do you know this is true? And they said, it's the given.
Okay.
Nice. Yeah. I said, ooh, that's a geometry thing. Yeah, they said it's a given.
Try to throw that in there a little
Yeah.
bit.
So, but what was your question?
My question was, how can we expand on where she was saying we were doing these critical thinking at the lower classes, and now we're moving to the higher class? What would be a good example of showing that critical thinking at the algebra 2 level?
Oh my gosh, so much. Like when we're graphing like quadratics, then we get into the word problems and, trajectories and just stuff like that.
So more of a connection to the real world situation.
Yeah, like,
do you see that at your level, but at a smaller level?
Yeah, it's just thinking that it's almost as if algebra 1, you learn the steps, right?
yeah.
The steps, the process. Geometry, you learn why those steps and why those processes are in place. And by the time you're in algebra 2, not only are you using these 2 steps, but you're applying it. And you're applying it to real world ideas and creating your own problems based off of others. So I can see that progression throughout.
I think too, hopefully they're making a connection. We were talking about this the other day. They don't always see the connection. Some of them get it. Like the x-intercept or the roots of the equations. Like we're not sure that all of them are getting it. We were talking about that the other day. But hopefully some of them see that the x-intercepts of your graph are, your zeros. I don't know if that they make that connection in algebra 1. Some of them do, maybe.
But you would say that
But
hopefully
hopefully
after 3 years of abstract thinking,
that they're getting it.
that
And not all the algebra 2 students do. They don't.
sometimes it takes it even another level
Yeah.
to things to click together.
For everything,
So in summary, we've seen a lot of these concepts that flow, and we can each describe at the different levels where they are. You agree?
Mm-hmm.
And that in general, it's not just main concepts, but it's also the critical thinking and the process of solving that makes the mathematics connect between each class.
Yeah.
Yes. Thank you.